Happy Thursday, everybody, and welcome back to Everything Mathematics. And today we're going to continue our series on number theory and estimation rounding off on a whole. And today we're going to be specifically looking at how to round off to the nearest 100, 10, and whole number. Previously to this, on Monday, we look at the concept of estimation and rounding off. Why do we do it, purpose, and so forth. On Tuesday, we went on to look at how to round off, looking at decimal places. Yesterday, we looked at significant figures. Today, we're going to look at the nearest 100, tens, and whole numbers. And tomorrow, if we live to see, we're going to look at standard notation or standard form. Rounding off using standard form, standard notation, basically. So, what are we going to do today? Objective? Simple. So today we're going to simply look at how to round off to the nearest 100, tens, or whole number. And this is just three examples. You could round off to any amount. You could round off to the nearest thousand, the nearest million, the nearest cent, and all these things could come to play. Maybe we could look at those vocabularies later on the line, but don't feel that it's only three ways you could round off to the nearest whole, if you understand something. Good. So how do we go about rounding off to the nearest whatever? So simply, so supposing we have a number. So supposing let's come up with another generic number. So we have 185. The whole concept is the same. And when I say it's the same in terms of identifying the cutoff point, adding one, or leave it just like that, that whole idea remains the same. The only thing here now is that we have to identify which number is our critical value, the number that we look out for. So if I measure a quick chart, so of course we have tens, we have hundreds, we have thousands, and we have whole numbers too. If we have a whole number, it simply means that it's like we're looking at a unit. So let's call it ones, and these are place value. So if we're looking at the nearest whole number or a unit, you have to look at the first decimal place. And I'll explain this. This might not make sense to you just now, but you will get it just now. If we're looking at the nearest 10, then that means that we have to look at our ones. Or, let's put it better, we have to look at our units. Let's look at it like that. If we're looking at the nearest 100, then we have to pay attention to our tens or tens. I should write that tens with a capital. Let me take that over. This tens supposed to be with a capital T. We pay attention to the tens. And if we let me say we're rounding up to the nearest thousand, then our critical value is in 100. So we have to pay attention to that H, that 100 place. So for example, look at this number here, 185. And we know the place values, right? So we know that this is 100, this is tens, this is units. So the 1 is 100, the 8 is 10, and the 5 is units, because this is a whole number. So all I'm trying to explain in this chart here is where you get your critical values based on what I ask you to round off. So supposing I have 185 and let's say I ask you to round off to the nearest 10. So if I ask you to round off to the nearest 10, then the critical value that you look at is the units. You look at the units. And this will tell you whether you add 1 to the tens or you keep the tens like that. So in other words, whatever number of nearest decimal place I'm asking you to round off, you always pay attention to the unit just before that one. So you know before tens, not the unit, sorry, the place value before it. So you know for tens, the place value before tens is 1. For hundreds, the place value before the place value before hundreds is 10. And that's how you basically round off using the nearest whatever. So if I ask you to round off 185 to the nearest 10, again, nearest 10, I pay attention to the units and I do the usual working. So if this is greater than, it's 5 or greater, we add 1 to the 8. So this round off to the nearest 10 would be 190. 190. Just for fun, if I ask you to round off this to the nearest 1000, remember for the nearest 1000, we always look at the unit before the 1000, so we pay attention to the 100. And in a case like this, if you round off this to the nearest 1000, our answer will be 0. Yes, believe it or not, it will be 0. And last but not least, I could ask you to what? Well, now I can ask you to round off to the nearest whole number because it's not a decimal. So only tens could play. Oh yes, I could ask you to round up to the nearest 100. So if I ask you, no, I just did that. I could ask you to round up, no, I can't do the nearest 10 either because for the nearest 10 I need units. Good. I need a decimal, sorry, and there is no decimal here. So that's the same thing as the whole number here basically. Right? Actually, we just did it 10, so we can't do the nearest whole number because we don't have a decimal. Right, and that's basically the gist of it. Let us see if we could do another random one. So supposing I have 2,572. And let's look at all three of them. Let's look at the nearest 10, the nearest 100, and the nearest 1,000. We cannot do the nearest whole number because we need a decimal. We need at least the first decimal place to do the nearest whole number. But hopefully in one of our workouts we have one of them. So if I'm doing this to the nearest 10, remember this is our tenth. So our critical value will be the 2 here. So this to the nearest 10 will be equal to 2,570. Right? Nearest 10. Just write that quickly. This will be to the nearest 10. Good? Because, again, I pay attention. I underline my 10, and my critical value for 10 is units. Critical value for 10 is units. Always the value before it, or the place value before the one that you're asked for. So, good. So, that's for that. Supposing now I ask you to round up the same number to the nearest 100. So, again, this is my 100. And my critical value is always the unit before the 100. So for 100, the unit before 100 is tens. So I pay attention to my 10. If it's 5 or greater, I add 1. And in this case, it is. So I add 1 here. So to the nearest 100, it will be 2,600. Yes? And this will be to the nearest 100. So notice same number, but when round off to two different values or different places, notice that we're not really getting the same number, and that's okay. That's how it is. And now if I have to round off to the nearest 1,000, again, this is my 1,000, so I pay attention to the value before the 1,000, which is 100. This will be my critical value. My critical value will be the 5 here, the 100. And this 5 is 5, not greater but 5. So if it's 5, remember we have to add 1 to this, and everybody has become 0. So 2,572 round off to the nearest 1,000 is actually 3,000. I have an abstract understanding of this, but honestly that abstract understanding is hard to put into words. But the whole idea basically is if you find a value that is halfway closer to the higher value than the lower value, basically the value goes up. And I know that probably makes no sense to you. But I said it anyways because at the end of the day that might help somebody. But that is how I generally tend to look at it. So if I look at a smaller value, for example, and this is something that we do, but sometimes we don't pay attention. So supposing you go to the shop and you come back with some change. Supposing the shopkeeper give you $1 and let us say 25 cents. If sometimes we do it, but we don't pay attention. If I ask you how much money you get, and I know it's easy to say 125, but let us assume you didn't pay attention to your cents, but you know you got some cents. We know you got 25 cents. To be exact, we know we got 25. But something that we do instinctively, I realize in Grenada especially, if I ask you how much change you got, you go say you get $1 and some. $1. Yes? So you round off automatically and say you get $1 and some. Why you said that is because whatever money you got, you know it was closer to $1 than it was to $2. And that's the whole idea of rounding off to the nearest whole number, tens, whatever. On the other hand, supposing you got $1.80. And this is something, as I said, we do, and this whole idea helped me to understand how to round off. But I don't know if it makes sense to you, but it helps me. So again, I'm just throwing it up. If you get $1.80, and again, you're not paying attention to the cents, but you know you got 80 cents, you know you got a good amount of cents, let's put it like that. And I ask you how much money you got from the shop. The average one of us will say, I get something close to $2. Or you might say, I get almost $2, almost 2. You wouldn't say you get one something now. No, you would say, I got close to 2. And I don't know, I could be wrong, but you check around and inquire and find out and see if people would say that too. So 125, somehow you end up saying I get a dollar and change. But 180 now, you find yourself saying no, I get almost $2. And that's the whole idea behind rounding off to the nearest whatever. The whole picture here is that we know instinctively that 50 cents is like the cutoff point. It's like the point that determines whether we go up or the point that determines whether we go down. Well, guess what? When dealing with the other nearest rounding off, it's the same idea. It's the same 50-50 idea, the same halfway point. If it's greater than the halfway point, you just go up to the higher number. If it's lower than the halfway point, you go down to the lower number. Not neglecting that you don't have sense, but you're approximating. Remember, this is all under estimation and approximation and rounding. So it's not like it's not like you're saying you didn't get cents or you didn't get the 80 or the 25, but you're simply saying that these values here are closer to a bigger whole or a smaller whole. Hope that makes sense. I'll leave you with that thought there. So let's move on. Let's do some of our own, of course, and this will concretize what we just did. So, of course, at this point, you could pause the video and see if you could solve this on your own. I am not sticking. I am moving on, and let's see if we get the same answer. So, here we're rounding off 1,235 to the nearest 100. So, remember, we identify our 100 place. Our 100 place will be the 2 here. So, our critical value will be the 3. So the 3 is less than 5. So our answer here would be $1,200. And that's again to the nearest 100. Nearest 100. Good? That's it. That's our answer. Story done. Here, oh nice. Here we have one to the nearest whole number. We didn't get to practice this one. But remember, to the nearest whole number, we just look at the first decimal place. If you go back about 2 seconds, after 2 seconds, just about a minute ago from now, you would see that we had that. So to the nearest whole number, we look at the first decimal place. And this is the same example that we looked at earlier. And let me draw a bigger picture here for you without looking at the whole mathematics part of it. Think about this as money. So imagine, let me write it over. So imagine this is the same as $12.58. Think about it this way. I don't know if this helps you. And if I ask you to round up this to the nearest whole number or to the nearest dollar, as we might say, quickly we will be able to see that this is the same as $13. Well, let me not say quickly, but this is what we should be able to see. And why would we see that? Because we know that we get higher than 50 cents. It's 58. Yes, it's close to the borderline, but it's higher than 58. So that will automatically bring us to $13, if that makes sense. Anyway, I just said that to concretize what we did earlier, but let's just follow the rule. But again, all that's part of the rules. It's not who say we have to be traditional about it. So to the nearest whole number, of course, we look at the first decimal place. And in this case, it is 5. So remember, once it's 5 or higher, we add 1 to the number before it, which is the 2. So this will be the same thing as 13 point, and everybody else becomes 0. So it's the same thing, 13.00, and this is to the nearest whole number. And to the nearest whole number, I could tell you it is synonymous to one decimal place, and sometimes it's also synonymous to the nearest dollar or the nearest cent. But no, not the nearest cent. I'll take that back. The nearest cent is like 2 decimal places. Yeah, 2 decimal places. Not that. Right. Moving on swiftly. So here we have 18.0092 to the nearest 10. So again, for the nearest 10, we look at the 10 place here, and our critical value will be the units. So the answer here will simply be, bam, 20. That's it. 20 to the nearest 10. And that's when we round it off to the nearest 10. And of course, if you want, it doesn't change anything, but if you want, you could put 20.0. 20.0. Doesn't change anything, but some persons like to see the point because they have a point, but 20.0, 20 is the same thing. And then we have 3,429 to the nearest 1,000. So again, we identify our 1,000 place, which is the 3. And our critical value for the 1,000 is 100. So the 100 is what we pay attention to decide whether we go up or we go down. And in this case, the 4 is less than 5, so we have to go down. So then that brings us to 3,000 to the nearest thousand, and that's the answer. To the nearest, I think we got that in one of our examples. I can't remember if it's the same number. To the nearest thousand. Yep, and that's it. So 3,000 to the nearest thousand. And believe it or not, that brings us to the end of today's video. So again, like, share, and subscribe as always. If you haven't subscribed as yet, turn on the notifications so you will always get notified when I send out a video Monday, Tuesday, Wednesday, Thursday, Friday. And of course, feel free to like, comment anything, not like, but comment anything in the comment section in the event that you want clarification or you just appreciate what was done. Until then, again, see you all for tomorrow's video, which will be the last one for this week on standard notation. Until then, you take care.